Hi everyone. Our team recently discovered a bundle option that combines Simcenter Femap and Simcenter 3D. Its product code is SC12504, and that allows you to either run a Femap or Simcenter 3D session, as well as access an additional purchase pool of value-based tokens. Now, in our case, we felt a pool of 100 tokens gave us enough access to the solvers we knew we would be using, and to some we eventually wanted to use as our staff grows. This combination is powerful for our analysts, but the question we most often get from our customers is, what's the difference between Femap and Simcenter 3D? Now, the main difference really resides in the software's architecture. Whereas Femap is a mesh-based pre- and post-processor, Simcenter 3D is going to be a geometric-based, multidisciplinary environment. On the left of your screen, you can see some of the different types of analyses in Simcenter 3D. The flexible body with 3D motion, that's what's shown here with this loader, as well as material modeling, and you can do that all within one geometric-based pre- and post-processor. So the question becomes whether you want to have associative geometry through the life cycle of your product, or begin with an input file to do your final modeling using the finite element method. But both of them can create input files from multiple solvers, and it is for this reason our team has added this bundle to our product list. We use the finite element method on a good bit of our analysis, but having that flexibility of the multidiscipline environment opens us up to so many more capabilities now with this product SC12504. Now, as I mentioned, the product bundle works with value-based tokens, and I wanted to list some of the types of analysis available to you. Not all of these can be accessed with 100 tokens, but most of them can. And this token pool is a heck of a lot easier than, say, having to purchase and manage an individual license for each solver. One solution in particular I want to focus on is this one with Design Space Explorer, which is really just HEED's multidisciplinary design optimization. HEED's standalone is a multi-portal application, and those portals allow you to access and automate other third-party applications. But as I mentioned, if you're working in Simcenter 3D with a token pool, you essentially have access to a single portal version of HEED's. Now, following this video, we're going to walk through a typical structural analysis workflow using Simcenter 3D and the Design Space Explorer vis-a-vis HEED's to achieve the following. Now, our scenario, we will be looking to optimize a part, and this can be done outside of a finite element solution, the outcome of which we're going to want a lightweight solution without compromising the structural integrity of the design. Now, inside of this, we have the flexibility to change anything we set up in our solutions. We can look at changing materials, change, say, the thickness of that material. We can move stiffeners. What we want to see is how does that impact the weight of our part compared to our stress? So I want to show the steps first of the workflow, then follow up with the actual demonstration of the modeling in 4 subsequent videos. It is important to remember that we'll be performing this demonstration using Simcenter 3D and the value-based token pool to access the Design Space Exploration solver, but I want to point out that this optimization can also be done using Femap. The main difference is that Femap has one database that's going to combine the Fem and Sim. That's it. But let's look at the Simcenter 3D process. We'll start with the geometry that's in the part file, which is just an extension of NXCAD for file format. You can create a part file from scratch or import your geometry from any parametric CAD. One of the parameters around feature-based history trees still intact, or parasolid step files, STL files, OBG files. That's the thing. When you're working inside of the Siemens Accelerator portfolio, you're going to get the maximum amount of flexibility when it comes to an open framework. Whatever you choose, you build your geometry, and that becomes your input to your finite element model. You'll get a .fem file and a .sim file, and then those 3 become your input that builds your basis for your optimization in HEED's. Looking at the part file, we're going to idealize this part you see here. We'll take away the blends, remove the unnecessary holes, we'll create a mid-surface mesh, and we'll set up the thickness changes for the web as well as position changes for the stiffeners in the FEM file. Once we're done with the geometry, we'll define our materials, our properties, and actually create the finite nodes and elements. With this sim file, this is where we will define how our part reacts to its environment. We'll want to know how loads are applied and how the constraints are applied. Then we'll run the linear static solution with Nastran. So this solution is what will be imported into Simcenter 3D and ultimately become our input into our HEEDS solution. When we're ready to work inside of HEEDS, we'll want to be familiar with what capabilities we are getting. First and foremost, you are getting a process automator. Lots of teams love this aspect because they may not be equipped or say they may not want to do any coding or as limited amount of coding as possible. They love the fact that this process is automated to just set up a design of experiments and just run through every possible combination that you can do. More than this, though, HEEDS is going to manage your folder structure. It's going to make the updates. It's going to execute the solution, store the files, and then retrieve the data, and then allow you to even manage it. Who knows? Maybe someday it will make your coffee for you while it's executing the solution. But really what it's going to do is search that design space and there can be 100,000 plus possible combinations, which could amount to an inappropriate amount of computational time. So the real strength in HEEDS is the search algorithm embedded in it, which is now even using some AI features. This algorithm is called Sherpa. It starts with the baseline and then learns as it is searching through the mins and max solutions. It's driven by the most efficient way to get from the baseline to the optimum solution. When we actually run the solution in HEEDS, you'll be able to see the generated results while it's running. The final feature we'll see with HEEDS is the strength of the post-processing data, be it in 2D or 3D plots. You'll see we can create statistical analysis, correlation plus influence plots. The goal of which is to help us interpret the data to make the most informed decisions based on our study. So I hope you'll follow along in this demonstration with us. Be sure to subscribe to catch any future videos in this playlist or really any other product demonstrations. So we'll see you in part 2 of this series. Thanks for watching.